Good evening, everybody. If you have any questions, let me know. Otherwise, we'll start working on some more stuff here. Yesterday, we looked at how to create views and what is the use of a view to some data. If you're going to grant privileges to other users where they can see the data or do some changes to the data. And we also talked about a view in a read-only format, meaning a view will not allow any changes if somebody tries to do changes. Then we also talked about sequence. Sequence can be used to generate unique values. Mostly in Oracle, people use sequences for generating value for a primary key column. And later on, when we learn about triggers, we can see how that can all be automated to generate values for a primary key. So when we talked about views, what I would like to do today is to introduce you to synonyms. And before we do that, I would like to create a scenario where synonym will be very useful. Okay. So first of all, what we'll do is I need another connection so I can log into user one. So let me first do create a new connection. I will send create new connection, and it looks exactly like the Scott connection, but only difference is here I will call it as user one, and the user is user one, password is password, and we'll test this connection. If everything looks good, like success here, you can save this. And now we have this new connection here. So double clicking, this is a user one. Okay. So this is a session for user one, and this is our Scott user. So now we have two windows open, so we can switch between them. So first of all, we got a requirement to create a view. And I think we created a view yesterday. Let me check if what views we have by doing select star from tab. And here you can see that VM2 is a view we created. But let us say we'll create a new view today. Well, let's ignore that existing one. So let us say our requirement is to say, for example, select star from EMP. And what we have in the EMP table is a lot of data. And I would like to show only certain amount of information. So let's say, for example, I will say select ename, comma. Actually, let's just use this query here. Ename, comma, job, comma. I don't want to show the salary, but I would like to show hire date, and let's say DEPTNO. These are the columns I want to show. So first I'm showing you what columns we need. Then the second thing we also will do is where department in, we will pick two departments, 20 and 30. Let's say we did the similar view yesterday. So now we are not showing all users, and also we are restricting users to see some columns. So we'll create a view for this, create view. Okay. Yesterday we have privileges to create view. So we are creating a view, v underscore emp table. Okay. I'm just going to call this as emp table. Only few columns and rows. Okay, let's say it is a very valid name. Only thing we have to check is it should be less than 30 characters in length. This is a view name. And in production, you might see such scenarios where view names are very long. And also remember, we had one more clause here with read only. Okay, so this is one more thing I will add here. So now let's create this view and see if it can be created. So here you can see identifier is too long. That means the name is long. So let's say a few rows, columns. Okay. So I just removed the end. So let's see what happens here. Now it still says identifier is too long. So calls and rows. Let's see if this will work. Okay. Now the view is created. Okay. Now there is one more syntax I want to show you. There is a word called or replace. Okay. Let's see if this will work. create view, create or replace view. So that's how the syntax should be: create or replace view. Okay. So what will happen here is, if this view already exists, it will replace it. If that view does not exist, then it will create a new view. So here it is not going to tell you whether it is replaced or not, but it tells you that view has been created. So what now, how do you query this view? Basically, you will just say select star from this view. Okay. So now what is going to happen is you will see this output of whatever you want to show to the other user. Okay. Now remember that you can even manipulate this data. You can say, for example, hire date plus, let's say, some 10,000 days. Okay. So you can do that manipulation. So nobody will know that you're doing manipulation because, hold on one second, must be expression. Okay. So what we'll do is, you remember the column aliasing? We have to do a column alias. Okay. So now this table has, this view has been recreated. And if you look at the data, you can see that all the dates have been updated to latest, like say, they're not in 1980s anymore. They're showing 2008. You know, this is just to show you that you can create a view of any query, and that's what other users will see when they query this particular view. Now let's grant a privilege, grant select on this view. So let me copy the view name. View name is long. There is a reason I created it that way. On to user one. Okay. So now I'm going to grant the select privilege to this user one. And what will happen now is, this user one will be able to do select star from Scott dot view. Okay. So now let's run this. You see how you can query. Okay. But what is the problem now is, every time this user wants to query, he has to write this long name along with the username Scott dot view name, right? So what is the use of synonyms is, this user, if he has enough privileges, he can create a synonym. Let me grant those privileges first. Grant create synonym like that to user one. Okay, so he can create any synonyms. Now I'm granting this privilege. Without that privilege, user one cannot create anything. Okay, so also let me say here, this is a system login. Okay, so now I will say, I don't want to write this long name every time I want to query. So I would like to call this as something else, like say alias or a different name, a short name. So now this user, what he can do is create synonym. Okay, and then you have to specify what is the synonym name you want. Okay, synonym name, let's say for example, EMP, SEMP. Okay, something like that. A simple name, synonym EMP for what is the long name. Okay, so if you do this, what it is going to do, it is a simple syntax here. What we are doing is create synonym. What is the synonym name for what is the object it is creating that synonym for. Okay, so that's all you have to do. Now, if you run this, it is going to create a synonym called SEMP. Now onwards, when you do select star from SEMP in the user one, you can query the same table which has that long name. Okay, so this is how a synonym works. Basically, why you are using it is, in production, you will see that there are some tables which have a long name. You can create synonyms to make it short. And now you can start referring it with this short name instead of writing that whole big long name. Okay, so that is the use of synonyms. Now remember one thing, as long as your base table you have granted privileges, the other user can see that. Let's say, for example, you suddenly take the privilege back, select, so let's say revoke select. on whatever this table is, okay, from user one. So whether it is a table or a view, when I remove the privilege, I remove the select privilege. Now user one goes back to his synonym and says select star from, it changes to table does not exist error. Okay? Because now we don't have privilege to query this particular view or a table. We don't know what the object is. Somebody told us use this table or a view, but now suddenly we see that the table or view does not exist because we don't have privileges. So privileges play a very important role. Like say for example, now I'll grant this privilege back so user one can again query. Okay. So in production, you might not keep on changing these privileges, but it is very important to know how to use these privileges and how they affect. Okay. Yeah. What is the question?
For synonyms, like if I just know that SEMP, how would I know like the base table which is related to that? Like, is there any way to track back the base table?
Yes. Yes.
Suppose, okay.
Yes. So, so obviously, you created a synonym. You want to know where this table is referring to, or what is the base table it is referring to. There are ways to do this. First of all, what we'll do is first query we can run is select star from tab just to see what exists in our schema. Okay. So here you can see that SEMP is a synonym. That is the basic thing you can check. Okay. So then what you do is there is a table called select star from user underscore synonyms. Okay, like that. And when you query this, it is going to show you what is the synonym name and who is the owner of the table and what is the table. Okay, does that answer your question? Okay, perfect. So that's how we use the synonyms. Now let's go back to Scott user. I'm going to change this scenario a little. Like we are so far looking at creating other objects and stuff. Also, we talked about granting privileges, removing privileges, and so far we did a lot of stuff. Now, what we want to do is there is something called indexes. So what is an index, first of all, is if you are talking about data, if there is a lot of data, okay, let's say, for example, EMP table, okay, and let's run this select star from EMP. What I want to do is I will create a table where I will have tons of data, okay, and then we'll do some searching to see how the data search works, okay. So without an index, like if you're reading a book, you have an index in the front which tells you which chapter starts at what page, and then there is a detailed index at the end of the book which has every single word used in the book and a reference to which pages it exists on. So that is an index which actually narrows the data to certain pages. So that means you can go quickly and figure out which row contains what data, right? So indexes are similar. Now what I will do first of all is, if you remember, we can do create table as query. So let me do a emp2 as select star from emp. You remember this particular command, right? So now what happened is here, if you notice, table emp2 is created. Okay. So then what you can do, select star from emp2. So right now we have this EMP2. I'm going to query the EMP2, and you can see there are a bunch of rows in the EMP2, like 15 rows. So now what I will do, there is an interesting thing I'm going to do. We don't care about the data duplication here. What I will do is I will insert into EMP2 and by selecting data from same table, okay, EMP2. So can you imagine what will happen? It will select 15 rows and insert those 15 rows back into EMP2. Okay. So now you have 30 rows. So just to count how many rows are there, count star from EMP2. you will see how many rows are there, right? So right now we have 30 rows. So let me build up some scenario here. Let me say select star from emp2 where job equal to manager. Okay, and let me make this manager in capital. Okay, so this is how you query. So you can see how many managers are there. Blake will exist second time because we copied the same data. Okay, now this is how you can quickly create some test data. Okay, let me show you something here. Let me do a count of. So let's say count of how many rows have this job manager. You can see there are 6 employees. Now the scenario here is job does not have any index on it. So, and also data is like 30 rows. So it is working okay. But now if I run this insert statement, you see this insert statement here. If I run this several times, it is going to select the data and put it back into the same table. So it gets multiplied. So when I run it, you can see here 30 rows inserted, 60 rows inserted. It keeps on growing. And with like 10 clicks or so, like say, for example, now I will do more clicks. Okay. I'm just running that query again and again to insert more and more rows. Okay. What I want to do is I want to make 1,000,000 rows in there. So here, if I run this command now, let me clear this screen. So you have like 2 million rows now, nearly 2 million rows. Okay. So that's a lot of rows in table. Now let's count how many managers are there in our table. And you can see it is still running fast. Okay. So let me create a scenario where it doesn't run fast. So let me run it again. So I'm now taking 2 million rows and inserting back into the same table. I'm inserting again. So now it will take like 4 million rows and insert back. Okay, obviously now I have space issue. So leave it at that. Let's say how many rows are in this table now. Okay. Oops, that was a wrong command. I mean, whatever it did, that's all right, but it was a wrong run. So I just have to count how many rows are there. There are nearly 4 million rows. Okay. Now, if I run the same command again, this thing will take some time. Slowly, performance will decrease. Okay. Here I'm not able to show you the performance effect, but let me see. It took for fetching this count. Let me do one thing. Let me fetch how many rows it is running. Basically, it fetched 50 rows. Okay, let me say distinct e-name. Okay, I want to see what are the e-names of these people. Okay. Now, in any case, our server is running too fast. I'm not able to show you the slowness in the query. Okay. So just imagine if this query takes too long, meaning let's say if the query taking 5 minutes to return the data, what you have to do is you have to create an index. Now, index is usually created on two things. First of all, index creation itself takes a lot of understanding of how to tune. But in this case, I'm going to generally tell you because you're writing a where clause where job equal to something, I will write a index on the job. Okay. So create index name idx underscore. Always you can see that Oracle follows the syntax of create object name index on emp2 and it is on the job column. So on emp2 table in brackets I have to specify what column. Okay. So that is the syntax for creating an index. Now I create this index. What will happen is now, it is not able to create the index because I don't have space. Okay. Now let me do a small magic here. I will grant a privilege, grant unlimited table space to Scott. Don't do this on your production systems. Ask your DBA to extend it. Okay, so now let me create this index and it is still failing because there is no space. Okay. Uh, okay, because it's given giving you that error. Let me just truncate this table. Truncate table M2. Okay. It's going to release all the space. It's not going to have this 4 million rows. Okay. But now we'll be able to create our index. Now you can see here index got created. Okay. Now imagine with having this index, what will happen is now when I run this select distinct ename from EMP2 where job equal to manager, what it will do is it somehow knows every single row where job is manager. Okay. So then it will be able to show the employee names faster because it knows where to look for. So indexes are interesting, like you can create indexes. Now having too many indexes is not good. If you have too many indexes on a table, then Oracle, every time you insert data or modify data, it has to go and update those indexes. Indexes are nothing but they're like another data structure where they keep some data. So be careful with indexes. If you don't have index, you will not have performance. If you have too many indexes, then you will have very low performance. So you have to be careful about indexes. Okay. Now, at this point, we actually covered a lot of SQL, meaning how do you interact with the database in a command mode. We haven't written any programs so far. So let's get our feet wet with PL SQL. Now, first of all, what is PL SQL, right? So we talked about SQL, and SQL is nothing but structured query language. Meaning when it was created, they said, okay, RDBMS needs a language where it is very structured to query this data. So a lot of people, came up with the structured query language syntax and they said, okay, let's make it English like. So that's why you say, okay, what do you want to do with the data? I want to insert data. So insert into table values. What is that you want to insert? That is English like. Same way, I want to select data. Okay, select what columns you need from where and how do you want to get your data out with the where clause. Okay, so what is the filter? So they tried to make it very English like. Now, only problem with SQL is a single command mode. Like you're going to type one command, execute it, server will come back and say, okay, that command was successful or failure. So then what happens is now you cannot keep on writing these commands. You have to actually write some programs which can be executed later as a bunch of huge number of commands in one file. So Oracle introduced something called PLSQL, which is procedural language and structured query language. Okay. I'm not going to write the whole thing, but I'm just saying it is structured query language. So what they did is once you put this procedural in the language, what happens is you need a language. Obviously, it should support all the functionality of if conditions, loops, and you can do data processing inside a program. And the advantage with PLSQL is all PLSQL objects, let's say once you get to procedures, functions, triggers, packages, those things live inside Oracle, meaning they are stored in the database and they're compiled and stored in database. So they perform faster and also they give you very good performance. So this is the basic introduction to what is PLSQL. So let's get started with PLSQL. First of all, any language should support data types. So we talked about a lot of data types when we introduced to SQL. SQL has this varchar data type, character data type, number data type, let's say date data type, and then you had like other data types. So PL SQL also has its own data types which are not supported by SQL, but it's only supported inside the programming language. Let's say, for example, one such data type is Boolean. Okay, Boolean, and what Boolean accepts is Boolean will accept true, false, or null. These are the three values Boolean will accept. Okay, this is a extra special data type provided in PL SQL, and boolean does not exist. I believe it does not exist in SQL. So if you want to test, you can just say create table XYZ. You say, for example, A is a boolean, and just run this command and it will immediately tell you if it supports or not. Okay. So you can see it says invalid data type. But inside PLSQL, this boolean exists, meaning we'll be able to use the boolean as a data type. Give me 1 second. Okay. So let's get started with PL SQL. First of all, what I would like to introduce is uh, any programming language has a structure. Like, when you get to C program, you might have to do certain things in a certain way. So let me introduce by using Notepad. I'm going to introduce how a PL SQL program structure looks like. Okay, PL SQL program structure. So first of all, in PL SQL, we have to write something called declare. Okay, let me write it as capital letters, declare. Okay, here what we do in this section is we write variable declaration. Declaration. Okay, because we are going to do some programming. So we'll declare all our variables which we need within our PL SQL program. Then what we do is we start the PL SQL program, and obviously it has to end somewhere. Okay, so begin and end is where you will actually write your code. You will say, this is my logic. This is what I want to do inside the program. So all your program logic goes here, program logic. Okay. Now there is one extra section which is optional, but very important is if you happen to have some errors in your programming logic, then how do you handle those errors? If you don't handle, it's a very bad programming. So there is something called exception section where you're going to handle errors. Okay, error, let's say error handling. So this is how you write your PL SQL program. Okay, all all these pieces are very important and they have to go in order. First you have to declare, then you begin, and then you declare, you handle your exceptions, and then end the program. That's how the structure is. So let's keep this in mind and let's look at our first program. Okay, first of all, let me close this cart thing, and also let me close other unnecessary windows. We don't need them right now. Okay, and what we'll do is we'll clear these errors and all that stuff. Query results, we don't need all that. Okay, so now we are going to use the SQL developer to continue to write our PL SQL programs. There might be little differences if you write it in SQL Plus, but for now, we'll get started. So we talked about the program structure. Now, any programming language, what people do is, first of all, when they write their first program, they write something called hello world. Okay, hello world is print something on the screen. Okay, now how do we print something on the screen from a PLSQL program is we'll use something called dbms underscore, let me write it in small letters, dbms underscore output dot put underscore line. Now you have to definitely remember this. You cannot say, oh, this is too long, I cannot remember. You have to definitely remember this because this is how you're going to print anything onto screen. Okay. Now I will say hello world, and this is the first program anybody writes in any program. If you go to C programming, this is what they will teach, how to print hello world. Okay. So let me run this as a script. Now you remember this PL SQL thing, we are going to run as a script. Okay. So when you run it, oh, okay, hold on. There is a small bug inside my code. It should be like single quotes, not the double quotes. Okay. Okay, so let me clear this screen again and run it. So here what happened is now I wrote a program. It successfully executed, but it did not give me any output other than PLSQL stored procedure or PLSQL procedure successfully completed. It clearly tells you that there was no error. But at the same time, where is my output? You don't see the output. So what we have to do is before we run this, we have to set something out. Okay. First of all, what happens is the server, when it prints something out, that is by default disabled. Okay. Now why it is done, I don't know, but by default it is disabled. What we have to do is set server output on. We have to do that. Okay. Now once you do that, you know how the semicolon is the end of each line. You don't see the begin with a semicolon, but end is with a semicolon. Okay. Now what we'll do, we'll clean the screen again and rerun it. Now what happened is, now you see this message which says successfully completed along with our output. Okay. So if you're not seeing any output, that means your set server output is off. So remember that. So this is very important. If you don't set it, your DBMS output will not print anything. So let's experiment with this a little bit more. Okay. What we'll do is we'll take this and build out, let's say, for example, a nice output. Let's say I will say stars like this. Okay. And then I'm going to say some spaces here and then put some more stars and then copy this and put it here. And now when I clear the screen and rerun this command, I want to show you that we can build out all this nice output. Okay. So what we are doing with dbms output underscore put underscore line is this particular word here. We are telling print this thing on the screen. Okay. Print it as a new line. So, and then you put in brackets and a single quotes, you're telling what to print, like here, stars, whatever you want to print. Okay, that is your first assignment where what you did is, okay, hello world is the small program we write. Okay, now let's look at few more things here. What we'll do, instead of just printing hello world, let's say what we'll do is we'll want to print some mathematics. Let's say, for example, we'll say instead of just doing hello world, what we'll do in the brackets is 2 into 10. Let's say what is the multiplication of, let's say, 22 into 10, let's say. And when I run this, you can see the output is result. Okay. Now, how would I show, let's say, for example, I want to show some other output like say 22 into 10 equals to, okay, whatever is the result. So let's just copy this. I'm going to show you how this output looks like. So give me 1 second. I'm just writing out the query. I'm in the program. Okay. So now I want to show you when I run this thing, it will look like this. Okay. So it comes in 2 lines. Now, how can I put that in one single line here is there is a concatenation like this. Okay. Now, remember one thing is dbms underscore put underscore line expects you to have everything in character mode. Okay. So let me write this, try to run it and see what happens. And then I will explain. Okay. Now, sometimes you might get error. Okay. Why I was telling you that is it will expect this to be a character data type and concatenation is nothing but addition, like it is going to add. Okay. So what it did here is it automatically did a to char of this. So what you can do is explicitly you can say to char, you know that function, you are converting it to character data type and then run it. It looks exactly good. Now you are going to do this just to avoid any errors in future, but it's always a good idea to have only character data type printout because there is no like dbms put line, it will expect it to be a character data type. Okay. So anyway, now you know how to do some math. Now let's say extend this program to a little bit where we'll use some variables. Okay. And what we'll do is declare. Now, how do you declare a variable is you will say, for example, a is number. Okay. And let's say b is another number and c is another number. Okay. So let's say we have 3 numbers, the 3 number variables. And now we'll say, now we have to say, for example, a is 22 and b is 10. then you will multiply that. Okay, A is assigned to 22 and B is assigned to 10. Okay, meaning this particular symbol of colon equal to is the assignment. That's how you assign a value. Now then C is assigned to A star B. Okay, this is a math formula. Okay, so now let me extend this. Now here in the output, we are not going to do the output this way. Instead, we'll say A into B. Okay, so for example, how would you put this, right? So you'll say, okay, 2 char, right? 2 char, let me remove this, 2 char of A concatenated with, what is that you want to concatenate with is X. Okay, concatenate with 2 char of B, right? Concatenated with equal to sign. Okay. Now here in this particular command, I'm not going to do any math. I'm just printing the output. That's all. I'm not doing any math here. Okay. And then finally put a concatenation and I'm going to end it with a dot. Okay. And then close the bracket and semicolon. So now you can see here, this is where I'm assigning the A value, B value, and then calculating what is the result. And then on this statement, I'm not doing any math, but just printing out the result. Okay. So let me clear this screen first. So I don't have anything in the result. And now I'm going to run this. You might not see a big difference, but now what we are doing is actually we are not setting up this 22 and 10 in the output, but we are setting it up here. So let's say, for example, we'll change this to, let's say, 225 and 100, and then clear the screen, or we don't have to clear actually, we can show the result. So you can see the result changed. Okay. Now, what if you don't want to assign them here, but you can assign them at the declaration level itself. So let's say, for example, we can also do, let's say here, we can say equal to 100, okay, and then assign to 25. That I'm assigning in the top level and calculating here and then displaying the result. So this is two ways of doing it, right? So let me run this again and you can see the result is good. So the way we are doing it here is along with declaration, we are actually setting the values. Now, what will be the value of C before setting it up? So this will be null because it's not set up. It will treat itself as like say, as if you assign null to it. Okay? That's how it will think. So by default, it will be value null. Now play with this a little bit and then you'll understand what's going on inside. So let me show you something with if condition. So we want to do some if condition and then checking and then all that. Okay. So what we'll do, we'll get rid of all these numbers. Okay. We will only need one number in this next program. So we'll say, for example, this is 55. Okay. So let's think of this as the age of the person. Okay. So then age is, let's say 20. Okay. Now, if condition goes like this, if you can write a condition, then do something, okay, do some logic, and if, so end that, okay. So now the condition goes in this. Let's say, for example, age is less than 20, okay, age is less than, let's say 30. Then write something. It's a dvms underscore. I told you that you have to remember this output underscore put underscore line. Okay, if once you use it like 10 times, you'll remember it. Okay, so now you'll print, let's say less than 30. That's how you're going to print some output. Okay, so this is your logic basically. If at all age is less than 30, then do this and end if. So that's how you will write your if condition. Okay, so let me clear the screen. This is a different program, so I'm going to run this and show you the output. It says less than 30. So whatever input you gave, age is less than 30. Let's say age is less than 30. So now let's make this age as 64. Okay. Now we'll run this again and show you the output. Nothing comes out. You can see here age less than 30 was the previous one. But for the new one, program is successful, but it is not printing anything because what you told is if age is less than 30, then do this. You did not tell what to do if it is not less than 30, right? You did not provide that condition. So if condition also allows you something called else. So let me introduce you to else. So what you'll do else, okay? If the condition is not met, then do something else, right? So let's say, for example, age is not less than 30 will be your output for the else part. So it is very straightforward. If age is less than 30, then this particular thing will execute, the first one. If it is not less than 30, then this will execute. Now you're declaring your age here, remember that, okay? So then if I run this program, it clearly tells you age is not less than 30, okay? So this is how your if condition works. Now, let us say you want to have some more extra conditions. Let's say, for example, if your age is 12, okay, or let's say, for example, 16, we want to call it as teenage, okay. So we want to extend this particular clause of if conditions. We want to make it much more complicated check. So what we'll do, if age is, now remember between, age between. Now this between was introduced with SQL when we did our where clauses. Between. Now let's say, for example, age is between 1 and, let's say 1 and, let's make it 11. Okay. Then we'll want to print something. Okay. We'll say, for example, kid. Output is kid. Okay. Then what if this is not the age? Okay, we want to check another range. Let's say, for example, else if. Okay, like that. So remember one thing here, else if is not written as this. You can also write that, but then you have to end it again. So you can write it else if like this. There is no E and there is no space. Okay, remember that. Now we'll say, okay, age is between 12 and 20. Okay, 12 and 20, that means 12 and 20 are included in this range. We'll just call it as teenage. Okay, teenager, something like that. Now we want to check another range. Let's say, for example, we'll take another range here. So we'll say, for example, 21 to 30. So let's say, for example, this will go into college. Okay, that's how we'll write the next range. And let's just end the range with, let's say, for example, we'll make 31 to, let's say, 60. Okay, works like a job. Okay, now if it is not any of the above, meaning anything more than 60 or less than 1, it will fall into this else condition where, let's say for example, does nothing. Okay, so simple example. I'm not insulting anybody, but I'm just saying some condition, right? So this is how the program looks like. Now we put the age in 16 and we are going to manipulate that age in one place. Okay, so now let's run this command. I mean, run this script, and you can see that 16 is teenager because it falls into this condition here. Now let me tweak this a little bit. Let's say make it 26 and then run it again. it says going to college because that falls into this category here. Okay. And then let's say, for example, make this 66 and it obviously says does nothing because of this else condition. Okay. So this is how a if condition looks like when you write if condition. So this was the introduction to if condition. What we'll do is we'll look at one more thing for tonight and then we'll end the session today and then we'll come back and look at more programming tomorrow. Okay. Now there is a popular program. People say, okay, show me how will you print 1 to 10. It's a easy stuff. Okay. So in PLSQL, there is something called loops. And first thing we'll use is for loop. Okay. For I in 1 dot dot 10 loop. Okay. What we'll do is, because you remember when we finished our if, we said end if. In the same way, we have to say end for sorry, end loop is loop, but it just ends with a end loop. Okay, because this is a loop here. So now what you have to do is, what is that you want to do inside the logic here? So let's say, for example, dbms underscore output dot put underscore line. Okay, and then you will say, for example, I just want to print I. Okay, so this has nothing to do with age, but remember that we are not using that age inside anywhere. I'm just using I here, and also remember that you don't have to declare I. Okay, PLSQL will declare it for you. So run this, and you will get the output of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's a simple loop. We just print 1 to 10. Now you can have this number any big or anything small. Okay, what you can do is here you can say, for example, I want it to be 1001 or 1010 to, let's say, for example, 1015 or 14, whatever you want to do, a smaller loop. Okay, so you can declare that loop and it will run. So remember that 1010 is included, so it will print that and goes up to 1014. Okay, it goes up. Now there is one more interesting thing you can do. You can do something called in reverse. Okay, so here inside the loop you can say reverse. So what it will do is, now it will start from 14 and go down like this. Okay, so I think that's it for tonight. I mean, we looked at several. Oh, we can actually do some more loops. Actually, we have enough time. So for loop is very important because now you know what is the upper limit, what is the lower limit and the upper limit, and you don't have to declare I, and you can print that output within the loop. Okay. So what we'll do is we'll talk about some more loops. If you have any questions, let me know. But we can cover a little bit more. Now let's say I don't want to print everything, but I want to print even numbers. Okay. So how do you print even numbers? Let's say, for example, you want to go from 1 to 10, but you want to print even numbers. You don't want to print anything else. Okay. So in this case here, because it is a hard coded up going up, let's remove this reverse keyword. And also we don't need the declare section. Okay. So when you run this, it only shows you 1 to 10. You don't have any other conditions here. Okay. You can actually write a nice if condition, if say, for example, mod of something, then do something else. But what we can do is, instead of writing this type of condition, we can use while loop. While loop is another kind of loop, and we can use that. So what we'll do is we'll declare a variable here. Okay, declare variable I is number, and we'll assign it to 2. Let's say start with 2. Okay, and then we'll say, because it's a while loop, here while loop is while. Okay, first let me introduce how the while looks like. While, you need to write a condition here. While I is, okay, I is less than 12. Okay, or maybe you can write I is less than or equal to 10. Let's do that better. Okay, what you want to do is you want to print I. Okay, and then end the loop. But remember here there is no incrementing value here. What happens when I run this is it will print 2 because first value is 2. It will print 2 and then it will continue to be in the loop because it will never reach 10 because we are not doing any increment. So I want to run this and show you. Most likely we have to cancel it. Okay. So now it basically, okay, it is expecting something else here. There is no space here. Okay. So first of all, there was a small mistake in bug in our code. Okay. So also there is a okay, while this to this, right? Oh yeah, there is a keyword here missing, loop. Okay, while condition loop end loop, and in between the end loop and while we are writing our logic. Okay, so now when I run this, it is going to keep on running because what is happening inside is it entered into the loop and there is no end to it. Finally, after some time it stopped. What happened is actually there is error, but you can see so many twos got printed. Okay, so if I go all the way to the top, what happened is it basically run out of some limit, buffer overflow, and it raised error. Okay, so what happened here is server tried to run it, but it is not going to end. If you leave this with a higher limit, this will run for years and it will not end because what is happening, if you understand here, I is 2 and it is never reaching 10 because it just keeps on printing 2. So what we'll do here is I equal to I is assigned as I plus 2. Okay. Now what is happening, will be increasing I after printing it, will increase it to next value and keep being in the loop until I is less than or equal to 10. So now let's run this logic and you will see 2, 4, 6, 8, 10. And what if you want to print only odd numbers, you will increment it accordingly. Okay, so start with 1 and print 2, add 2. Let's say for example, if you do it this way, you're going to print only odd numbers. Okay, so while loop is very interesting because now you can create control what is your condition and also what is your increment based on that while loop. These things can be used with dates. Let's say, for example, while date is less than or equal to something, do some logic. Okay. So you can do all that kind of while loop. Let's talk about one more loop, which, so in the for loop, what we did was, you remember for loop for I in 1 to 10 loop. This is how we wrote the for loop. I, we did not declare when it was a for loop. We told where to start, where to end, and we did not tell what is the increment. It was always going up, or in the reverse case, it is going down. With the while loop, first of all, you have to declare I. While will not declare it for you. So we did a declaration here. We told what is the condition, what is the start value, and also we had control over how much to increment. So this is how a while loop works, right? Now let me show you one more loop, which basically does not provide any condition. You have to do everything on your own, which is just a plain loop. Okay. So what we'll do is loop, print the output, do some increment and end loop. Okay. Now this one is an infinite loop, meaning you're not telling where to stop. You're just telling start here and go, keep going. So let's run this and I want to show you what happens. Again, remember that if you do a small mistake, it might not give you error straight away. It might run for some time and then run out of buffer. Okay. When you understand what is happening, when you learn DBA administration stuff, you will know why it is actually erroring out. For now, I'm going to just run this, and you see it seems like running, and it ran actually for 3 million numbers. It actually ran for like really huge amount of numbers. And if you see the error, again, it shows the same buffer overflow error. Okay. Now, how do I exit? So let's say, for example, I want to print only up to 20, print even numbers. Let's say I want to print even numbers. Start with 2, increment by 2, but I want to print only up to 20. So you have to tell exit when, what is the condition? Condition is I greater than 20 will be your condition. Okay. So what you're saying is simply you do the print, you do the increment, and when exit when I is greater than 20, your condition is inside the loop now. Okay. So now this will run and it will show you output. It looks as if you're running a loop, but it stops as soon as it hits that condition of 20. So these are three types of loops. We talked about for loop. Let me clear this. We understood something about programming structure. We talked about for loop, while loop, and a loop, just a plain loop. But for this, you also need an exit statement. So you learned about exit when. So you have to exit on a specific condition. Okay. Okay. Let's talk about one thing here. I want to show you something. Say, for example, when we are writing that for loop, you remember we wrote a for I, it can be anything, j in 2 to 5 loop print, and we don't have to do anything here. And remember, j does not require declaration. If you declare j, then it will give you error actually, because for loop will declare its own j. It gives error. Okay. So okay, hold on one second. This is not a related error. Actually, this should be different. So let me run this again and see that it runs. Okay. Now what it is doing is it is not actually using this J because I can declare this to 200 and show you that it is not using. What happens is as soon as it hits this level, it will declare its own J and it will use that J within the for loop. Now here, if you don't have anything to declare, you can just do null like this. Okay. So let's run this. Okay, sorry, that's not a correct example. Okay. Let me show you another example. Let's not do this. And let's say I don't want to do anything. You know what? Actually, let's find a better example for tomorrow. Forget about this last thing. And what we saw in this class was we used the for loop, while loop, and loop. Actually, let me just summarize. What we did is we talked about synonyms, indexes, and then we started talking about PL/SQL. PL/SQL program structure has declare section, and you'll do some declarations here, variables, and then you'll say begin and end. We also have to do exceptions, but we haven't talked about that. Okay, so exception here, exception, and also here is your program logic, and here error handling. Okay, this is how PLSQL looks like. And also remember that all these statements end with the semicolon that we talked about in the program. We talked about if conditions, how to print some output using dbms output underscore put line. We talked about if conditions, for loop, while loop, a plain loop, and exit from that loop. So these are some of the basic stuff in PLSQL programming. Uh, Tomorrow we'll start talking about how to interact with the database. So then we'll work on these things a little more, and we'll see how to select data from the table, put it back into the table, and stuff like that. Simple database handling. Okay, thank you. And if you have any questions, let me know. Okay, good night.